We already talked about depreciation, the depreciation of capital investment, some additional information about depreciation and total capital cost. Okay, total capital cost and how it is calculated, which is the fixed capital cost plus working capital that we need to put. Fixed capital, we said that is a cost that comes with building the plant, okay, and also everything that is depreciable, so it can be depreciated. So land is our fixed capital cost, is the capital cost that we put, but it cannot be depreciated. As I said, land doesn't lose its worth, its value. Usually the value of the lands increase all the time. So working capital is again the amount of money that we need to put for the startup of the project, the money that we need to put to start the project, and usually for the first few months of the project to buy some equipment. I don't know, for offices we need to buy some stuff. For people that we hire, we need to provide them with some, like tools, softwares, whatever it is, for the first few months before the revenue comes from the investment. And as I said, the working capital is usually about 15 to 20% of fixed capital investment. So we reach up to this slide, and here I'm gonna talk a little bit about depreciation. As I said, depreciation is the amount of the reduction of the amount of reduction in the value of the asset or like equipment or the investment in the plant, in the project. Let's say, as I said, if you buy a new car, at the beginning the car costs, let's say, 19, is in $20,000 in the first year. In the second year, once you buy it from the company, there will be a big drop in the price of the car. Okay, so once you buy it from the company, there is a, let's say, big drop in the price. So if you want to sell it, maybe you cannot easily if you want to sell it, you may not be able to easily sell it. I look for a eraser here. A screen erase pen. Okay, so it erases everything. Anyways, so when you buy a car in the first year, the car, once you buy it from the showroom, is like, let's say, 20,000. Once you take it from showroom, okay, once you take it, let's say this is the first time that you buy, year 0, this is first year, there is a big drop in the price of the car. It's going to be like, let's say, after 1 year, okay, this is the beginning, I call it 0 times 0. After 1 year, the price is maybe like 15,000. After 2 years, okay, the price will reduce, but not like the first year, okay. Then it's going to be, let's say, 13,500. In the third years is going to be 12,000. It's something like that. So there is a big drop in the first year. So you see that the drop, the depreciation of the price, the reduction in the price will change in different years. Okay, from beginning up to and until the end. Until the end of the year 3, or after 3 years, there is a reduction in the price. But at the beginning, the first year, we have 5,000 reduction. In the second year, how much we have? We have 1,500. All right. In the third year, we have, again, it can be, let's say, it could be 11,500. Okay, 11,500. So we will have about $2,000 okay, we have like 5,100, 1,500, 2,000, or 1,000, it doesn't matter. Okay, so we have we have the depreciation reduction in the price, in the value of the car, that is from 1 year to another year is different, right? So how we can calculate this reductions? There are some in the plant, in the process, that we have different equipments. You have some specific methods. One method is a straight line, or we call it SL depreciation method, that consider a linear relation between the reduction of the price and the period. Let's say if each year we had reduction of 2,000, okay, each year we had a reduction of 2,000, then it was a straight line depreciation method. It's a linear relation. Each year the reduction is the same. We have another method which is called double declining balance, DDB, and also modified accelerated cost recovery system, MACRS. Those are some concepts, some methods that is used by businessmen, by accountants to calculate this kind of depreciations. I'm not going to go through detail of them. I'm going to talk a little bit about the first method, the straight line method, which is the simplest method. And for the rest, if one day it was really necessary, you can do a lot. As I said, there are a lot of information available about all these concepts. You can just go have a look at them. Okay, just kind of revising what we already talked, and some new and then defining some new concept. Okay, fixed capital investment is the capital investment that we need. Okay, fixed capital investment is the capital investment we need to build the plant, buy the equipment, build the plant, the buildings, utility buildings, whatever we need to build, it will be in fixed capital investment, like equipment, buildings, land, asset, whatever we buy in physical stuff is my fixed capital investment, or FCI. Salvage value, as I said, is the value of the equipment, or in general the value of the plant at the end of its life. Let's say if the life of plant is 15 years, 20 years, I don't know, some refineries they have even more than 50 years life. So the value of that plant, or the value of equipment at the end of its life, is called salvage value. And usually the equipment salvage value is a small portion in FCI, in fixed capital investment, because we have a lot of expenses for insurance, for land, for fabrication, for labor. And you see that when we were calculating the capital investment, the cost of manufacturing, you were seeing that the equipment, the material itself is not a big issue. We have a lot of expenses like labor, engineering, this kind of expenses. So the salvage value, or the cost of the value of the equipment, usually at the end is not a lot. Let's say if you use a car for 20 years, the car is not really useful anymore. If you use a heat exchanger for 30 years, it doesn't really have a value after 20, 30 years. That's why the salvage value of equipment is usually considered zero, and is a small portion in FCI. Life of equipment is the time that is allowed for the equipment to depreciate. Okay, life of the equipment here is not really the life. Is not the life of equipment that will be working. No, is a kind of useful life of that equipment, or in the life of the equipment. I mean, is a time, is a number of the years that the price of that equipment will reduce. The equipment will lose its price, lose its value. Okay, after let's say if you have a heat exchanger, after 9-10 years, it doesn't really lose its value a lot, so it's already zero. Like when you have an equipment like heat exchanger, when you use it for 10 years, okay, if let's say maybe after 1 or 2 years you could still sell that equipment, that compressor, with good value, but after let's say 9-10 years, nobody is going to buy it from you. Although it exchanger will work, but nobody is going to buy it from you. So that is the life. This is the life of the equipment. The time allowed for the equipment to depreciate, for depreciation. The time that the time period that the value of the equipment will reduce. After that, the value, let's say, at the end of that time, the value of the equipment won't be really a lot. We can even ignore it, and after that, it doesn't really depreciate because it's already lost all its value after that period of time. And for most of the chemical process equipment, like heat exchanger, towers, this kind of things, this life is 9.5 years. Total capital for depreciation is total capital for depreciation. We call it, or depreciation amount, we show it with D, is the difference between the initial fixed capital investment minus the salvage value. Initial fixed capital investment at the beginning minus salvage value, minus what we have at the end. So this difference is how much money we lose because of depreciation, because of the depreciation of the equipment. So total capital for depreciation is the difference between how much money we put at the beginning, how much money we recover at the end. This difference is how much money we will lose or how much money is depreciated. Then this difference is a total depreciation. Okay, it doesn't give us any information about the depreciation per year. This is the total depreciation in the project life, in the equipment life. Okay, if we want to know how much money we will lose per year, okay, so now then we have to define the yearly depreciation. D here is for depreciation, K is for the index that shows the year, okay, yearly depreciation. And depreciation can be different from year to year, okay, from year to year. And to which it depends again to the method that we use. If we use a straight line method, so we consider that depreciation each year is the same. If we use the other methods, we can use some equation that can really give us the depreciation in each year and is not necessarily the same. Okay, I gave you the example of the car, that the price of the car at the beginning, the first year, drop a lot because you just buy a new car and you use it. You buy a first-hand car, then it becomes second-hand car. But after second year, the car is already second-hand, so the price doesn't really drop like what happened at the beginning. And book value is the value of the depreciable capital that has not yet been depreciated. So, as I said, the total depreciation value is the difference between fixed capital investment and salvage value. Initial, what we put at the beginning, what we have at the end. This difference is the depreciation, total depreciation. This is the yearly depreciation. So if, let's say, my project life is, I don't know how many it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's say my project has a life of 11 years. Okay, so each year, first year, second year, each year I have depreciation. This is the total depreciation difference between fixed capital investment minus salvage value. But if I calculate the depreciation up to year 6, okay, so that will be what? That will be the sum of the depreciation until year 6. Okay, I show it in this way. Imagine I have yearly depreciation. I sum of them until year 6, and that sum will be the total depreciation that I have until that year. So if I reduce that depreciation up to this, okay, I mean up to this year, so if I reduce the depreciation up to that year, the difference is called book value, okay, is amount of depreciable capital that has not yet been depreciated. Book value is, so this is the total here, I mean the total, and the book value is this one that I just shaded, this part here, okay. So the amount of depreciable capital that has not yet been depreciated. So this is the definition of book value. Okay, as I said, we have several methods to find the depreciation. The simplest one is the straight line method, that we have a linear, there is a linear decrease in the capital, or there is a linear depreciation with the period of time. Let's say each year we have a certain amount of depreciation that will happen. Let's say each year there is this much that will reduce. All right, so it's a linear relation, and for that we need we can okay, as I said, book value is the difference between fixed capital investment, okay, minus the depreciation up to that year. That was the book value. Okay, so another method, if we have a linear relation, we can find the book value in this way as well, by using this equation. Okay, so is DSL and is the depreciation of in the by using a straight line method for a period of n, let's say n years, let's say 3 years, 4 years, n can be anything. It can be 3 years, it can be like this, 1, 2, 3, 4, 5 years. Right here is 3 years. So in the period, a period of time, P is the purchase price of the equipment, how much we paid for the equipment, minus salvage value until that period, okay, until the salvage value after n period. It means n is the life of the equipment, okay. As I said, for most of chemical engineering equipment, chemical processing equipment is 9.5 years, 10 years, something like that. So is the value of the equipment at the end of its life, and is the useful life of equipment, okay. So by using this, we can find the depreciation per each year, the price that we pay, minus what we recover at the end of the life of the equipment, that, as I said, most of the time is 0, divided by its useful life, that most of the time for chemical processing equipment is 9.5 years. Okay, now I'm going to talk a little bit about the cash flow diagram that we already talked about. It has a positive part, it has a negative part, and then we are almost done with this unit. So for the cash flow, what we have to consider when we want to plot the cash flow diagram. So we have to consider the purchase of the land, the building the plant that usually takes up to 3 years, 1 to 3 years, the capital, working capital, or the money that we have to put to a startup, for the startup of the project, and then plan to start producing products and revenue. Okay, after the capital, it start up to here is all negative. From here, that the plant starts producing revenue. Okay, so the revenue, I mean, it start produce some product, and the revenue will be going up. It will be positive, and again, there is a period of time that it takes for us to collect as much as money that we already spent here for buying the land, for buying the equipment, building, fabrication, capital, working capital that we put. So, and also during that period that the process start to produce some product and we have some revenue, we have we have depreciation of our capital. I mean, we have our equipment that they will lose their money, they will lose their value. We have cars, trucks, a lot of equipment that they lose their value. We usually consider 5 years for the depreciation, and then we consider a life for our plan, let's say 10 to 12 years of life, that during that life the plan will produce some profit, and we will consider those. We have to do some profitability analysis at the end. At the end of the project, after let's say 12, 15 years, okay, what we will recover at the end of the project: working capital, the money that we put to start the project, that will be recovered; land that we already have, that will be recovered; and also salvage value. As I said, for many equipment, salvage value is zero, but let's say after many years, the company has some assets that, like some cars, some still, some of them are useful. Some other, like let's say the company has a lot of metals, that second-hand metal that can be recovered, recycled, so those can be sold. Let's say, for example, in our college in CNAQ, we have keyboards, laptops, or PCs that are from 20 years ago, or I don't know, they are from 15 years ago, so they are not really usable anymore, right? But still, maybe they can be recycled or recycled. Or maybe if we sell them to a company that recycled them, maybe we can get a small amount of money from the company that is recycling them, right? But in general, nobody is going to use a laptop or a PC that is 20 years or 15 years old, right? So cash flow diagram is a diagram that looks like this figure here. So in x-axis, we already talked about. In x-axis, we have our time, which is usually year. Then at the beginning, we have, here we have positive cash flow. Here we have negative cash flow. At the beginning, we have all these expenses. We have to purchase land. Okay, that is a lot of money. We have fixed capital investment, is a period that we have to pay for equipment, building, fabrication, installation, everything. Then we have working capital, WC, is the money that we have to put at the end for the startup. Okay, to start up, this is the startup point of the project. To start the project, to let's say we need to buy some, I already talked about it, we need to buy some some equipment for offices, for the site, something that is really necessary to start up the project. After that, the project starts creating some revenue. And usually in the first year after startup, the revenue is not that much. That's why this line here doesn't have a big slope. But after the first year, okay, usually it takes for projects 2 to 3 years for the startup. Let's say if the project starts up at year 2, in the first year until first year, it means year 3, it produces some revenue, but it's not that much. That's why the slope of this line is not that much. And after that, after the year 3, the revenue will be much better. So that's why you see this line has a bigger slope until somewhere here that we call this, that until here that we reach to net revenue, net money that we have will be 0. This is a period up to here, let's say 8 years of after 8 years actually. So it's between 7 to 8, or let's consider it 8. Okay, is a time that the money, the revenue that I have, and also here I consider all the depreciation. For my capital cost in the first year, some of the price of my equipment drops. In the second year also the equipment price will drop. So like all this curve, what is this curve? It considers the revenue that we have minus what we will be losing. The revenue we have, what we are losing as a money is the value of my equipment that is depreciated, that will be depreciated, the taxes that we will pay, if we have some extra expenses we have to pay. So those are all considered here. Revenue minus any expense that we have and depreciation of the equipment. So after a certain time, let's say after a few years, we reach to a point then that we will have positive money or positive cash. Okay, here we have negative cash, here we will be zero in cash, and here we have some positive cash that we call this is a kind of profitable period. And okay, from the startup until we reach to this profitable period, that is, we call this depreciation period. And if you consider that project has a life of 12 years, at the end of year of 12, the project will be stopped. Okay, so the total life of project is, okay, from we start the project at this year, but until year 2, we were building the project. At year 2, the project is started. From year 2 to 12, which is 10 years, this is the working life of the project. And we will finish the project here. The project will be ended here. So this is how much cash we made from the project, the benefit that we got from the project, plus what we can recover at the end. At the end, what we can recover is the land that we put. We can sell the land and we can make money. The working capital that we put at the beginning, we can recover it. And also salvage value. Let's say if we sell the equipments, the old equipments, cars, trucks, whatever we have, we can make some money. And you see that salvage value usually is very small value for the fixed capital investment that we have. Salvage value, this is the money that we put for the equipments, construction, everything. From this money, this much money, from here to here, okay, what we can recover, only this much, this little amount here. All right, so this is kind of general description of cash flow diagram. Now I'm going to, okay, we have almost 5-6 more slides and then it's finished. So then about profit, okay, the profit that we make, we have to do some evaluation, some analysis for the profit as well. There are two general methods, non-discounted method and discounted method. Okay, let's say your project start giving you some positive cash starting from after 8 years. So let's say you are in Qatar, or I don't know, in Canada, anywhere. So your project is here. You pay the profit. You had all your expenses in Qatari riyal, right? So you did these expenses during this 8 years, or 8 years ago. You did all this money in Qatari riyal, but now you start getting some profit from your project. But are this money that we are getting, again, your project is in Qatar, your income will be in Qatari riyal. Are the Qatari riyal that we have today has the same value as 8 years ago, or not? That's the concept of this slide is talking about these two things. Non-discounted method is that if we don't care about the value of the money, we don't take into account the value of the money. I know that 8 years ago I spent this much Qatari riyal, and now I'm getting my revenue again in Qatari riyal. But let's say maybe the Qatari riyal, the ratio between Qatari riyal and US dollar, because US dollar is a reference currency, right? Most of the business work based on US dollar. So Let's say maybe 8 years ago, the Qatari riyal was more expensive than US dollar, now is less, or vice versa. The Qatari riyal was, let's say, it was less expensive, the ratio was less, now it's better, right? So if we take into account this kind of, we call it value of the money, the value of the currency or money that you have today. Okay, is it the same as before or not? If we consider the value of the money in our profit calculation, okay, so that is called, if you don't consider the value of money, that is called non-discounted method. Okay, non-discounted method doesn't take into account the value of money. This method is usually used for a small or a slightly improved or medium-sized project and is not recommended for big and large projects. Discounted method, we take into account the value of the money from the beginning of the project. Let's say the time zero that we start the project. We also consider the value of the money from beginning, and for whatever calculation we do, we take into account, we apply the value of the money in that time. Okay, so let's say if I have if I can calculate my profit today, so let's say my profit today after 8 years of working of my company, now I got 1 million Qatari riyal profit. So I will compare this, with the money that I put. Let's say I spent 2 million Qatari riyal. So totally how much I recover? I recover 1 million Qatari riyal. I spent 2, now I got 1 back. So but what I have to do, I have to see how much was Qatari riyal, the 2 million Qatari riyal that I spent 8 years ago, how much it was in US dollar, and the 1 million Qatari riyal that I got today, how much does it cost how much it is equivalent in US dollar. So then I make the difference and see how much money I lost or how much money I recovered. So I have to consider the value of the money in that time, and is usually useful for large project and is the most useful method, discounted method. So when we talk about profitability, there are different criteria for the profitability. Okay, so you can consider, when you want to do some profitability analysis, you can consider the time that you are getting your profit, or the amount of the cash you are getting your profit, or the interest rate. Okay, the rate of your profit. Okay, the rate of your profit. Let's say how much money you put at the beginning, how much money you made. Okay, so this gives you the rate of the interest rate or the profit rate. So there are like different criteria. Now I'm going to talk a little bit about them. Okay, so now we are in discounted method. Okay, discounted profitability method, or discounted profitability criteria. Just give me 1 second, please. So, for discounted, is a method that we consider the value of the value of the money, okay, from the beginning. So, in this method, what we have is, okay, there are some parameters that we need to calculate in this method. The first parameter is DPBP. DPBP. Okay, discounted payable, DPBP, discounted payable period, discounted payable period. Okay, what's the definition? Is the time required after a startup to recover your fixed capital investment. Time required after a startup to recover your fixed capital investment by considering the value of the money. By the way, okay, the value of the money is not only the currency ratio of the currency or things like that. Let's say it also depends to some other economical factor. Let's say, as I know, for example, in Qatar, many years ago, the interest rate for the loan was 10%, something like that, or maybe 15%. I don't know exact number, but I know it was a big amount. But now it is only 2%. Let's say if I had $1 million, 1 million riyals. So if I was putting in the bank, I could each year I could get 10% interest on that. Okay, but now I can get 2%. So it's really different. You see, like value of my money, and or even like there are some countries that let's say you have. The interest rate is for the bank is 2%. Let's say if you have some saving, put it in the bank gives you 2% interest, but the inflation in the country is 5%. It means although you get 2% as interest rate, but at the same time the value of your money is reducing by 5% because the inflation in the country is high. I mean, like your money like loses value like 5% per year, right? So you have to at least make 5% from that money to recover the reduction of the value of the money. So like, I mean, in general, this discussion, I mean, this topic is a very wide topic. It involves a lot of economical factor and like subjects that I'm not gonna really go through them. But just for your information, what is this definition? So the DPBP is the discounted payable period, is the time required after the startup to recover your fixed capital investment by considering the value of the money. For the cash criteria, okay, for the time criteria, we will use a period, we will use a time. For cash criteria, like each of these factors, these parameters, they are an indicator of the profitability of your plant, of your company. That's why we need to calculate them. If you are using time criteria, we will calculate this parameter. If you are using the cash criteria, we need to calculate the cumulative cash position, how much cash we have discounted, cumulative cash position. Let's say up to two day, how much money, how much cash I have in general, in total. Okay, totally how much cash I have. Cumulative, it means considering all negative and positive. And there are two indicators for this criteria. One of them is net present value. They call it NPV. Or net present worth, they call it NPW. So there are two indicators for this that we use. And all the cash is a discounted method. All the cash, they have to be discounted. They have to be discounted to a present time T0. Or I mean, it means like this sentence means we have to consider the value of the money from beginning, from time 0 at the minimum acceptable rate of return that we already defined this parameter. So again, NPV, net present value, okay, is the amount of the money. Okay, I mean like profitability. When I talk about profitability, it means at the end of the project how much money we made. So NPV is how much total net cash we have at the end of the project by considering the value of the money, discounted cash value, cash position. Discounted means we already consider the cash value of the money value. And we can for the profit we can show it with this parameter or this parameter, net present value or present. This is PVR. I will have it here. Yes, PVR is present value ratio. Present value ratio, PVR, present value ratio, is the present value of all positive cash that you got divided by the present value of all negative cash. Okay, this is again another way to show the profitability. How much positive cash that you had at the end of the project by considering the money value divided by all the negative cash flow that you had, all the expenses that you had, all the benefits that you had. So the ratio is also a ratio that shows how much money you made, the profit of your company. So next, so we have interest rate criterion. Just give me 1 second, please. So we talked about time criterion and cash criterion. Now interest rate criterion. For interest rate criterion, we need to also define a factor, a parameter that represents this criterion. The factor that we will use here is discounted cash flow rate of return. Cash flow rate of return, or we show it with DCFROR. Cash, discounted cash flow rate of return. Okay, rate of return is a bit different from the net money that you get. Rate is usually unitless. So is the interest rate, is the profit rate, is something like this value is the interest rate, or is the profit rate that all the cash flow must be discounted for the net present value to be equal to 0. Okay, so is the interest rate that we have to use and reduce from, and discount and reduce from all the cash flow that we had to reach to net present value equal to 0. It's kind of interest rate, profit rate or interest rate. So DCFROR, again, interest or discount rate, for which the net present value of the project will be 0. Let's say if the net present value of your project today is I don't know, $1 million. Okay, net present value of your plant is $1 million. Let's say how much, with which yearly interest I have to reduce from this. Okay, let's say if my project life was 10 years, with which interest year, which interest rate in percent I have to reduce from from this value in 10 years to reach to 0. Okay, that will be your DCFROR. Okay, the interest rate that we have to reduce from the net present value in the period of the project to reach to a net present value of 0. Okay, in non-discounted profitability criteria, I'm not gonna talk about again in non-discounted profitability criteria. Again, we have time criterion, cash criterion, and also interest rate criterion. That I'm gonna just talk about interest rate criterion. That non-discounted, as I said, we don't consider it. We don't take into account the money value, the value of the money. So when we are going to talk about non-discounted profitability by using this criteria, we will define the profitability by using this parameter: rate of return on investment. Rate of return on investment, or ROROI. ROROI. Rate of return on investment. So what is ROROI, rate of return on investment? Is the average annual net profit divided by fixed capital investment. It's very simple. So is average how much is my net profit per year divided by how much money I put as a fixed capital investment. So rate of return on investment, how much money is returned to you from your investment. How much money you put at the beginning for the investment, fixed capital investment. We don't consider land or working capital here, only the fixed capital investment. And we have to calculate the average net profit. Net profit means how much money you earn minus how much expense you had, okay, each year. Okay, this is based on year. Average annual net profit that you got from your project divided by the fixed capital investment you had at the beginning. And again, non-discounted means the time value of the money is not considered. Okay, last slide in this unit is okay, talking about when we consider the time criteria, when discounted, when non-discounted method, when time criteria, when cash criteria, when interest rate criteria. So those are really depend to the type of the project, how big or small is the project. Okay, so those are the parameters that really affect the choice between each of these methods. Okay, and then okay, so for so like those are the parameters that will be those are the kind of common or I mean, like when we want to compare two projects, let's say we have project number 1 and project number 2, they are kind of two independent, mutually exclusive. You remember from FCIL, like the project that are independent, they don't have anything to do with each other. I mean, one project, if we change one project, doesn't affect the other one. If you have two mutually exclusive large projects, okay, when we want to compare them together, the criteria that we use are mainly those are the criteria that we will use to compare them. Which one has a lower PBP? PBP is, I'm not gonna talk about it, is an economical factor. It's called price. PBP, price to book value ratio. Price to book value ratio. Price to book value ratio, or we call it, this is R, PBR. Okay, price to book value ratio. Which one has the lowest price to book value ratio, the highest net present value, and PBR, if you remember in the previous slide, is the present value ratio, net present value ratio, and which one has highest DCEF and or ROR. This is for discounted method. This is non-discounted method. Rate of return on investment. DCF, it was, I think, discounted. Let me just look at my paper. DSFROR was discounted cash flow rate of return. Okay, discounted cash flow rate of return. Discounted cash flow rate of return. So this is for interest rate criterion. This was for cash criterion, and usually time criterion is not very popular.